Hey guys, what's up? So, welcome to the series of system design. So, today we are going to know about this very interesting and very popularly known concept of consistent hashing. You would see consistent hashing used in the industry in databases like Cassandra DB, DynamoDB, and so many other places. And there are so many evolved versions of consistent hashing also in today's world. First, before we get started, let's first understand the problem and we'll go through this series in this kind of fashion that first we'll talk about the problem, then we'll talk about the solution, then we'll discuss the trade-offs. So remember, whenever you're doing a system design problem, there is always trade-offs and you have to always define the problem first. So first define the problem because in a real world, the problem is huge. You have only 45 minutes to 1 hour. You cannot talk about every problem and every answer, right? So define the problem, create an MVP, understand what is the scope that you're trying to solve, and based on that, make sure that whatever you're solving for that much and you're agreed upon, right? So make sure these are aligned on. I'll make a different video on the guidelines for doing system design interviews. And yeah, so let's get started. So let's first define the problem. So the problem is that, hey, I have a user or a client. We come to this side. So I have a user or a client who is trying to access my website, let's say, and let's say this is a famous website like movie booking website or things like that. Let's say book my show for folks who are based out of India or folks who are outside of India. Things like Ticketmaster. You might have heard about these websites, which are things like movie booking websites, and there are multiple servers, right? Of course, thousands of servers running that are serving your requests, right? So you have the user reaching out to the server asking for some information, and let's say it's a very simple information that, hey, is seat number, so what are the empty seats available for my given movie X-Men, right? Let's say a movie X-Men is there in my nearby theaters and I have given a request. So the request says that the movie name is X-Men, movie ID is 123, and hall ID, which is the theater ID is 100. So based on these parameters, the user sends these parameters in the request and that goes to the server, one of the servers that are running, right? So out of many servers that are running, it goes to one of the servers and it lands in my database layer. So what happens in my database layer? All my data is stored in the database layer. Now think of a big application like Book My Show, District, Ticketmaster, things like that. You cannot have a single DB that would have all the queries, right? There would be millions of movies running. There would be millions of halls. So the combination of halls to movies is huge. So if you look at, let's say, a single city would have probably 50 halls, right? 50 theaters. And look at how many cities we have. So you have a huge number of theaters, and each theater is running at least 5 shows. So you can expect a rough number. I don't have a number at the top of my mind, but let's say there are close to 10,000 cities in the world, right? That are having theaters running. So, and the number of concurrent movies that are running is 5. So this number is roughly 25 into 10 to the power 5, right? So that's approximately 2.5 million records, right? You cannot store 2.5 million records in a single DB. That's why you need multiple databases. Now, let's come to the next point, okay? How do you store all these requests across these DBs? You cannot store the data in a single DB, right? As we just discussed. So let's say we have 5 different DBs where, you know, uh, zero point 0.5 million records are there in each of the DB. So 0.5 million here, zero point 0.5 million here, 0.5 million here, and so on. Let's say there are 5 DBs. Let's say n is equals to 5. Okay, and let's say, what do? You say that, hey, based on a certain hash function that I've created, I will find out which DB my data will have access to. So for example, all my movies of movie ID 123 and hall ID 100 will land on DB3. Okay, so based on that, based on the hash function, I can find out which hall this will land in. Okay, so essentially hash function is nothing but a simple method that takes, in this case, one parameter or two parameters or whatever, and it does a modulo of my total number of databases so that it never goes beyond 5, right? So when you do a modulo by 5, your number always stays between 0 to 4. Okay, is this part clear? If this is clear, you understand how the system works in Scratch. Okay, so this is general designing of a system. Now problem comes up. You scale up more. You think of going even bigger. You get more movie records. You get more sign-ups, right? More users, more movie records, more people accessing the database. So 5 DBs are not enough. Okay, let's say you need to add 2 more databases. Okay, so I'm adding 2 more databases. I'm adding 2 more databases here. Now, what do I need to change? I need to change my hash function to be able to accommodate these 2 more databases, because the same function that was working earlier will not work now. Okay, what will happen? I have to design my hash function in a different manner. I have my n value will now be 7. So if I do a modulo of n by 7, my existing records will still be pointed to here. These 2 new records will be completely empty, right? Do you want that? Even after adding 2 databases, most of your requests are going to these 5 DBs, right? So it's not equally distributed. That's the first problem. Okay, it's not equally distributed. That's the first problem. What's the second problem? Let's say one of the DBs goes down. It just thinks, hey, I'm not doing well. Let's go down. It's a bad day for the company. So DB2 says, I give up. You have overused me a lot. I'm gone now. So DB2 just gives up, and the engineers now are in a trouble. So you do not have almost 500,000 of records from your data. So a lot of users are getting error. The websites are crashing, the apps are crashing and all that. So what do? How do you maintain that, right? So what do? You probably have a replica of this. You probably have a copy of this somewhere else, right? You have a copy of this somewhere else. You need to add that in your list of databases and remove this one, right? So this gets added, this gets removed. Shuffling happens in your data, right? During that shuffling, you have only 4 DBs, 1 DB less you have, right? Or only 6 DBs running. So it cannot be instant. 1 DB going up, 1 DB coming down will take some time. During that time, so now you have 6 DBs while this DB is down, but your hash function is still pointing to that DB, okay? Your hash function is still pointing to that DB because you have not updated your hash function yet. So you're basically losing requests. You're losing requests of buying tickets. You're losing money. You're losing your business. So that's the problem of this kind of a design where you are trying to distribute your requests across different nodes. So these are all nodes in a system, and you're using a plain hash function. You can come up with various, different types of hash functions, but it will still be the same. You will always have these kind of problems. Okay, so that's the problem. Next, we'll be discussing the solution. So the solution is consistent hashing. What is consistent hashing? Consistent hashing is nothing but a way of distributing the hashing into different layers, into different levels in a circular fashion that we will see now, so that you are not facing the problems that we saw earlier. So the problems we saw earlier were, number one, what if a node goes down? What if a cluster goes down? What do? We are not serving those requests, right? And then you have to redistribute the hash again. Number two, what if you have to add a node, right? In that case, you have to redistribute the hash function and move data from one cluster to another cluster again and again. So that's a problem, right? So now we are going to solve that. So let's come to the solution. So the solution is consistent hashing. Before understanding consistent hashing, make sure you learn about hashing. What is hashing and what are hash functions? So first thing that we'll do is we'll try to imagine a hash ring. A hash ring is nothing but a virtual concept think of this as a circular space. Think of this as a circular space which starts from 0 and goes up to 100. Okay, 0, 5, 10, 15, 20, 25, 30, so on, 50, 75 and 100. Okay, now in ideal world, this is essentially nothing but your range of number. Think of it as 2 to the power 32, right? Or even more, 2 to the power 64 if you have a bigger range, right? Anything, you can come up with a bigger range also. But ideally, we see that, 2 to the power 32 is your range of integer numbers. So think of that as 2 to the power 32. And my circle is not circular, so ignore that. Anyway, this is not a real concept, so it might not be circular. But I'm bad at drawing, so yeah. So for depiction of this in the board, to understand, we have taken only 100 points, okay? So let's say our integer range is from 0 to 100. Now let's say we have 4 databases. 4 of them are placed at 0, virtually placed at 0, they are placed at 25, they are placed at 50 and 75. All the DBs handle the data up till the left of that, okay? So DB2 will handle the data of this area. DB3 will handle the data of this much area. DB4 will handle the data of this much area. And DB1 will handle the area of this much area. You can do it in another way also. You can think of this in just the other way. Let's say DB1 will handle this much data. DB2 will handle this much data. It completely depends upon how you implement this, okay? This completely depends upon your code, how you write the code, how is it written. It's completely normal to do it the other way, okay, as long as it's correct. Now, let's try to understand what's happening. Let's say my input, my hash function is like this. Hash function takes an input, let's say 33, which is my ID, okay? The result of that after whatever function is coming to 33, let's say. I'm just giving an example, okay? Let's say it's 333, you do a mod 100 and whatever, okay? All those things you are doing and you're getting 33. So 33 would land where? 33 is landing here, okay? So whatever is in this region should go to DB2. So DB2 will handle this request of 333 or 33, whatever. Same, let's do another exercise. So let's say hash of 772 and you're doing some kind of hash and you're getting the number as, let's say, 74. Okay, so if you're getting 74, where is this landing in my ring? It's landing here. It's just landing basically near to DB4, but it's in the range of DB3. So 74. So 50 to 74, DB3 is handling, right? So DB3 will go to DB3. Is it clear how consistent hashing and ring allocation is working? Now let's see what all problems we have solved out of this. We saw two major problems that were there as a part of the previous approach, basic vanilla approach that we had where we did not use consistent hashing, right? Now let's see what all problems we solved with this approach. Number one, what if a node goes down? So in the earlier example, we saw DB2 was not having a good day. It was like, let's give up. So let's say now DB2 gives up, okay? So DB2 gives up. I hope you're able to see DB2 is giving up, okay? DB2 says, I'm done. So now what happens? So basically, nobody is there to handle this much range of data, correct? Nobody is able to handle this much range of data, but the implementation is done in such a way that if DB2 is down, since there is no DB2, whatever, so DB1, so it basically, let's say now you get a query of 40. So 40 should be part of DB2 because it's in this area. But since there is no DB2, so this is going to my next available database, okay? Next available database is DB1. So it's going to DB1. DB1 is available, it can serve. So DB1 will take additional load and it will not lose any request. You'll not lose data. You will be serving more requests, yes. You'll be working more. So let's say if you have a team of 5 people, one of your guys just go on a sick leave, 4 people manage the workload, right? It's just like that. So that's the problem which is solved, okay? Number 2, what if you want to add a database, okay? So let's say I want to add a new database in this case. let's say I want to add it here. Okay, let's say I want to add it here. I want to add db. Okay, let's not add here. It's easier to mark if I add it here. Okay, I can call it db5. db5 is here, which is at 85. Okay, so anything at 85 marker is my db5. Okay, so basically now this gets split up. So now whatever was here gets, so whatever was here gets split up. So db5, this is split up and this is split up. So my db1 is now handling lesser requests. db1 is just handling this much and db5 is handling this much. Okay, so you understand how easy it is to add a database also without redistributing anything. I did not have to touch the other databases. I did not have to touch the entire hash function, right? I just have to redistribute the data of db1. So db1 earlier had the data of this range, entire this range, right? I have to just redistribute only for one database, whoever took lesser load now. So this much work of db1 now goes to db5 and the remaining work stays in db1. So that is as minimum redistribution as possible. That problem is also solved. Okay, so that is consistent hashing. Now let's also talk about a small caveat to this. You would also be wondering that, hey, db2 went down, right? And db1 was taking extra workload. Now db1 will also go down, right? If db1 is overworking, it's overburdened, it's heating up too fast, so this will also go down. db1 will also go down. So what do you do? So in real world, there is a concept of virtual nodes. Okay, there is a concept of virtual nodes. In virtual nodes, what happens is these databases are not exactly placed in these exact locations. They are replicated, okay? Logically, as you can understand, this is a logical explanation. This is not a circle. There is no circle in real life, okay? It's just a mathematical logical explanation, like a circular hash, okay? So db1, I can distribute db1 to be present here also, okay? I can distribute db1 to be present here also, okay? I can distribute db2 to be present here also. I can distribute db2 to be present here also. And I can distribute db4 to be present somewhere here. Okay, and db3 to be present somewhere here. Okay, so let's say I'm distributing all the databases into multiple locations now. They are just not managing a single range. They are managing multiple smaller ranges. So db1 is now managing this much and this much. Okay, so db1 is managing, db1 is managing this much, db1 is managing this much, and db1 is managing this much. Okay, so whatever payload, whatever load db1 was managing, it's now distributed into multiple ranges. Okay, so anything now, if say it lands at 33 instead of earlier going to db2 will now be going to, okay, db2 is still there, so let's say not 33, let's say 37 would earlier go to db2, right? But now it would go to db1. Because you have made smaller chunks of the virtual space, all the data is efficiently distributed now. Okay, so what happens now, because you have smaller chunks for each database, right? Smaller space and lesser load for each database. The total load remains the same, but the distribution is more scattered. Okay, so what happens now is if db2 goes down, let's say db2 went down, okay, earlier this entire workload of from 50 to 25 to 50, entire range was going to db1. So it's like almost double the data, almost double the workload. But now, since db2 is down, only this much data, db2 is handling only this much data for this region, right? db2 is handling only this much data for this region. So the workload of this much, so it's probably 10, right? From 35 to 25. 10 of these goes added to DB4. So now we have DB4 here. So 10 of these gets added to DB4. So DB4 plus 10. So I'll add plus 10 here, workload wise. Okay. DB2 is down. Remember, DB2 is down. Where is DB2? Okay, DB2 is here also. So this is also down because the database is actually one. There is only, actually there's a single database 2, DB2. There are 4 database, bare metal databases, but the logical spaces are different. So DB2 is also gone down here. What happens? Only this much data, right? Only this much data, which is from 75 to 65, goes to DB1. So DB1 now takes 10 more data. Okay. And DB2 here is also there, so this also goes down. So only, let's say 5 data, 5 ratio of 5% data gets added to DB4. So you can see how even though one database went down, that load got distributed among the entire cluster of different databases. It's not that just because DB2 went down, DB1 took the entire pressure. DB2 went down, that's why all the databases, if this is distributed properly, right? If this is distributed properly, all the databases will now get a proper share, a very equal and a decent share of extra workload. So everything will keep on working fine until DB2 is repaired and put back into work. So that is the concept of virtual nodes. The real node of DB1 is here, but there's a virtual node, a virtual pointer of DB1 somewhere here. There's a virtual pointer of DB1 somewhere here. DB2 is actually here, but there are virtual pointers here. There are virtual pointers here. Okay. So these are called virtual nodes. These are not the actual nodes, but they are pointers to those nodes. So that's the concept of consistent hashing, and that's about virtual nodes. So you will see this concept implemented in Redis, in Cassandra, in DynamoDB, in a lot of CDNs also. And this is one of the favorite problems of big tech companies like FANG, and they would ask you concepts like this, especially if you're working on storage type kind of teams. So it's very important to understand this algorithm, and to be able to implement is amazing. So I'll try to link the code for consistent hashing also, but make sure you understand the fundamentals. If there are any questions, feel free to drop in the comments. So this is a new series that I'm having. I'm starting a new series about system design. If you're liking the way I'm teaching, if you're liking the content, feel free to like, comment and subscribe. We'll add more content, and let me know what help do you need in terms of system design, computer science. That's about today's video. That's about today's class. Thank you so much for watching. Have a great interview.